Here's the thing that's shocking everyone in the AI industry right now. The progress that looked unstoppable is actually slowing down. Not stopping, slowing. And that's somehow more unsettling to the people who've been betting billions that exponential growth would never stop. For years, the narrative was simple. Bigger models, more data, faster chips equals smarter AI. Keep feeding the machine, and intelligence keeps climbing. But new research from some of the most credible voices in the field is painting a completely different picture. The scaling laws that everyone built their entire business plans around, they are hitting a wall. Think of it like climbing a mountain in the dark. For the first few thousand meters, every step up was clear. Your headlamp was bright, the path was obvious, and you could feel the altitude gain. But now, somewhere around the peak, something's changed. The steps are getting steeper. The oxygen's thinner, and climbing the next 100 meters is taking way more effort than the last 100 meters did. That's what's happening with AI right now. The cost to get the next leap in capability is growing exponentially, and companies are starting to realize they might not have the fuel to make those climbs forever. This is where the real story starts. To understand why this is happening now, we need to rewind about 5 years. Back then, the AI world had this beautiful, almost religious belief in something called the scaling hypothesis. The idea was dead simple. If you throw more compute at a problem, if you train on more data, and if you build bigger neural networks, the AI just gets smarter. It wasn't magic. It was predictable. Scientists mapped out curves showing that performance improved in a straight, reliable line as you scaled up. OpenAI used this insight to build GPT-3, massive, trained on enormous datasets, and it was transformative. Then GPT-4, then the open-source models started catching up. Everyone went all in on the same strategy. Google doubled down. Meta doubled down. Every startup with ambitions in the space doubled down. The venture capital money flowed because the mathematics looked ironclad. You've probably heard the hype. AI companies spending millions on chips, building server farms the size of office buildings, signing mega deals with cloud providers. It all made sense at the time because the data showed that the returns kept coming. But here's the twist nobody expected. There's only so much training data on the planet. The internet has finite information, and we're running out of it faster than anyone thought we would. On top of that, the computational cost to train each new generation isn't just going up, it's exploding. And that's just the beginning. Let's talk about the data problem first, because it's more serious than most headlines are saying. Training a modern large language model requires an absolutely staggering amount of text. We are talking hundreds of billions of words. The internet's largest datasets have already been scraped multiple times over. And here's where it gets complicated. A lot of the best data, the really high-quality stuff that makes AI systems actually useful, isn't freely available online. It's locked inside academic journals, proprietary databases, or behind paywalls. So what are companies doing? Some are turning to synthetic data, which means they are training new AI models on text generated by previous AI models. That sounds clever until you realize what's happening underneath. You're training AI on the output of AI. It's like making a photocopy of a photocopy. Each generation loses a little fidelity. The patterns get slightly more distorted. The original signal gets buried under layers of degradation. And researchers have already spotted this problem emerging in real datasets. Models trained on synthetic data start showing signs of what's called model collapse. They become less diverse, less creative, and less accurate than their predecessors. We are essentially hitting the ceiling on how much useful training material exists, and the workarounds aren't as effective as anyone hoped. This is what the real bottleneck looks like. But the data shortage isn't even the biggest problem. The computational cost is. Think about training an AI model like building a bridge. The first bridge you build costs you a certain amount of money and materials. The second bridge, with better techniques, costs less per meter. But what if every new bridge you wanted to build had to be twice as long as the last one, and it had to be twice as strong? That's what's happening with AI training costs. Training GPT-3 back in 2020 cost OpenAI roughly $4 to $13 million. By the time GPT-4 rolled around, estimates suggest the training costs had climbed into the hundreds of millions. We're not talking about 10 to 15% increases year on year. We are talking about costs that are doubling, tripling, or worse, with each major generation. And here's the thing, there's a limit to how much money even the wealthiest companies are willing to spend on a single training run. You can't just keep throwing compute at a problem forever, because eventually, the cost of generating a marginal improvement becomes bigger than the value you get from that improvement. When training the next model costs 5 times more than the last one, but only gives you a 5% performance boost, the financial math breaks down. Companies start asking whether it's worth it. And that's where we are right now, at the point where the returns are starting to look, well, less guaranteed. So what does the actual research say? The paper that's been getting the most attention right now comes from researchers looking at empirical data from real AI training runs over the past several years. When you plot capability gains against the resources spent, the curve that was supposed to be linear, that nice, predictable straight line, is actually bending. It's flattening. The technical term is saturating the scaling law, which just means we are hitting the limits of what throwing more compute can achieve. Some analyses suggest we might hit a point where the useful training data is essentially exhausted within the next 1 to 2 years. Not gone forever, but harvested to the point where finding new, high-quality information for training becomes incredibly difficult and expensive. Others argue we are already at that wall, and we just haven't fully accepted it yet. The disagreement between researchers is actually interesting because it reveals something important. Nobody's entirely sure how close we are, but everyone agrees the curve is bending. Everyone agrees the easy gains are behind us. What changes that narrative isn't more of the same strategy. It's something fundamentally different. But here's what the industry isn't talking about nearly enough. If AI progress really is slowing, what does that actually mean for you, for the industry, and for the companies that have bet the farm on continued exponential growth? First, the easy one, don't expect the kind of capability jumps you've seen in the past 2 years to keep happening every year from now on. We might get to a point where each new model release is noticeably better, but the jumps get smaller and the time between releases gets longer. That's not a disaster. That's just reality settling in. But here's where the implications get uncomfortable. Companies like OpenAI, Google, Meta, and all the startups building AI products have built massive organizations around the assumption of continuous, exponential improvement. Staff numbers, product roadmaps, investor expectations, all of it assumes the graph keeps going up at the same angle. If the angle gets shallower, those numbers don't work anymore. You start seeing layoffs. You start seeing priorities change. You start seeing companies that placed huge bets on scaling now scrambling to find alternative approaches. And some of them will fail because they backed the wrong horse. That's competitive reality. But there's also something more subtle happening. It's creating an opening for different approaches to AI. If brute force scaling doesn't work forever, then maybe the answer is smarter architectures, better reasoning systems, or fundamentally different training methods. The companies that figure that out first will own the next decade. And that's where things get really interesting. So if you're trying to figure out what this all means for the actual AI systems you interact with, here's the straightforward answer. The AI you use today, ChatGPT, Claude, Gemini, whatever else you play with, those aren't going away. They're going to keep improving, but the improvement pathway is changing. Instead of raw scale, you're going to see a lot more focus on what researchers call efficiency. Smarter training methods, better data curation, models that learn more from less. You'll probably also see a huge push towards specialization. Instead of one giant general-purpose model trying to do everything, you'll get multiple smaller, better-trained models that each excel at specific tasks. Companies are already experimenting with this approach because it's more efficient. Another change you'll notice is more focus on what the model already knows. Techniques like prompt engineering, retrieval augmented generation, and few-shot learning are ways to get more value out of existing models without retraining them from scratch. These methods were always available, but when scaling looked infinite, there was less incentive to perfect them. Now there's a ton of incentive. You should also expect to see massive investment in inference. That's the process of running a trained model to get answers, becoming more efficient. If you can't make models fundamentally smarter, you can at least make them faster and cheaper to run. This is the unsexy part of AI that doesn't make headlines, but actually determines whether products survive in the real world. Here's what you need to know as you're watching the AI space over the next year. The narrative is shifting from how big can we make this to how smart can we make this with what we have. That's not a failure of AI. That's actually how mature technology usually evolves. You go from exponential growth to optimization, refinement, and specialization. It's happened to every technology that's ever mattered: processors, batteries, telecommunications. They all hit scaling limits, and then they evolved differently. What makes this moment interesting is that we are catching it early enough to see the inflection point actually happening in real time. You don't usually get to watch a technological revolution change gears like this. The companies that understand this change and adapt their strategy will thrive. The ones that keep trying to push the old playbook will struggle. For you, as someone watching the AI space, it means the hype cycle is probably nearing a peak. That doesn't mean AI stops being useful or important. It means the conversation gets more grounded, more practical, and honestly, more interesting. Because now it's not about theoretical capabilities anymore, it's about what you can actually build and deploy in the real world. And that's where the real value gets created. Follow for daily AI news to stay ahead of these changes as they happen. Because this transition is going to create opportunities for people who understand what's really changing underneath the headlines.